Welcome back to CNC's Claims Corner. We are live at this episode 4, season 5, and I'm actually broadcasting live from beautiful Branchville, New Jersey. Selective Insurance was kind enough to give me a space here to sit down and go live from this. And this is kind of a throwback to the original Claims Corner or Flood News at Noon, how we started this. We started as in Zoom calls with a whole bunch of people on, and we got brought up a specific topic. We talked about that topic, and we brought in an expert to kind of give us their insight into that topic. And that's kind of how all this started. So we're kind of doing a throwback to that, which is fine. Um, Obviously, since then we've expanded. We've got our broadcast booth. We go live. We do recordings. We do all kinds of fun stuff. We're trying to make it more interactive with a couple of segments that we put in here. And so today with us again, Murphy and Julie are broadcasting. They're broadcasting live from our booth in our office in Mobile, Alabama, from our broadcast booth there. We have Hal joining us from, I think, where are you at? You're in Galveston today, or are you like in some unique town someplace that nobody knows about?
Live from Galveston, Texas.
Okay. And then Phil, he's joining us as well. He'll be joining us a little later. He's in Colorado. He's joining us. So it's great to have everybody on. And what we've done kind of in this episode, we are stepping back to a recording we did during our CNC Connect conference in Mobile, Alabama. We had a chance to slip away and sit down and have a conversation with Phil and Hal and talk about the upcoming hurricane season and also what happened in 2023. And we get into a little more details about ensembles and El Nino and future forecasting and categories and impacts and things like that kind of affect consumers out there and how to prepare and look at stuff in a different perspective versus what we kind of see on the National Hurricane Center sometimes. And you see this cone of uncertainty and you kind of focus on that. So, but before we jump right into that, Murphy, I know we have some housekeeping stuff we got to throw out there. And so I'm going to throw it over to you, Murphy.
Yeah, absolutely. So a couple housekeeping things. Obviously, we want to give our audience a way to keep up with us and to stay connected with us, not only through this season of Claims Corner, but in all of our future endeavors that will be on our socials and things like that. So we ask you to subscribe to CNC Catastrophe and National Claims. That's our YouTube channel, our official YouTube channel, as well as our other social media platforms. If you hit the bell icon on this video on YouTube or on our actual homepage for CNC, you will be notified of anytime we go live, anytime we post future content. And obviously that's important for us because that is our goal throughout 2024 and beyond, is to stay connected to our audience, to our adjusters, and to the people who mean the most to us in order to accomplish all of these things as we work. Another bit of housekeeping, I will do a small tease here. We were at PLRB. We just got back yesterday. A few of our team members are actually flying back today. We debuted our new team member, our new mascot, the Shark. We did name him. We took a vote. The vote has been tallied, and we will not give it out. You will have to go to our social media pages to find out the name. So we are pushing the traffic there. We want everybody to see for themselves. Don't you write it down, Craig. Don't you do it. So those are our couple of housekeeping things. Again, we've got a lot of upcoming training too. CNC Pro, you can speak to anyone in our RDL department. They can get you signed up. We are booked from now to the end of June. Got classes on the calendar. Obviously, seating is limited. These classes are in high demand, but we have plenty of opportunities for people to join. So please contact them if that's something you're interested in. As again, you try to keep gaining that knowledge and keep training. So that is all I've got. So without further ado, we will go ahead and jump into this week's pre-recording.
Welcome to another episode of Claims Corner. Hard to believe we're in season 5 of Claims Corner. We have multiple episodes of Claims Corners. And if you want to find out more about Claims Corner and look at some of our past episodes, visit us at YouTube at our CNC Catastrophe and National Claims channel, where you find a lot of good episodes about experts in the field and their perspectives on different things from weather to construction to engineering to all kinds of great information that is out there for you to enjoy. This is special episode, actually, of Claims Corner, because we're coming to you from our conference here in Mobile, Alabama. And with us today, I have two gentlemen that you probably will recognize right off the bat. You've probably seen them before. Most of y'all know who you are. Most of everybody knows who you are, but I'll let you guys introduce yourselves for those out there in the audience who do not know who you are. So, Hal, tell us about yourself.
Yeah, there we go. I'm Hal Needham. Some folks know me as Hurricane Hal. Working with CNC now for about 6 years. It's been a great experience, and just doing a lot of extreme weather analysis, flood risk analysis, and more recently, a lot of science education communication with GeoTrek.
Yeah. And I'm Phil Klotzbach. I've been in the Department of Atmospheric Science at Colorado State University more than half my life now, since 2000. Trying to figure out what makes hurricanes tick. Our group at Colorado State's probably best known for its seasonal forecasts. But I'm fascinated by hurricanes and any time scale between what's going to happen with the hurricane in the next hour to what's going to happen with hurricanes on climate change timescales, so 50, 100 years from now.
Well, I'm very glad to have both of y'all here. I'm glad you are able to make it down to our conference and actually speak in front of a great audience. And I think they learned a lot of information regarding hurricanes and hurricane forecasting and some of the products and some of the research that y'all are actually doing into hurricane forecasting. But I do want to get into some questions that I know the audience is going to want to hear about. One of them really happens to do with 2023. Originally forecasted to be kind of a average to below average season. I think there was a subtropical storm in January that came out, and it seemed like once that subtropical storm kind of came out, everybody's like, oh, wait a minute, we got something happen. But then you look at some of the, what are the programs out there and the systems out there that are looking, going, well, they're above average, they're below average. Like, I think I'll give you a couple of quotes here, like April 2023, University of Arizona forecasted a very active season. And then a couple weeks later, I think Colorado State University and the Weather Channel said their average season. Late April comes along. University of Missouri issued 10 named storms, which were more in line with being kind of below average, I think, at that point. And then May, NOAA announced 12 to 17 named storms with a 40% chance of near normal season and a 30 for an above average and below average season. There was basically at that point a wide range of conclusions at what was going to happen, but it ended up being the fourth most active season on record. Isn't that correct?
Yeah, so, there's a lot of different ways to kind of categorize hurricane season. So if you categorize it by just the number of storms that formed, those systems that are named by the National Hurricane Center, it was the fourth most active on record. We had 20 named storms. An average season has about 14. Some of the other numbers, say like the number of hurricanes, was actually we had 7 hurricanes last year. The average season actually has 7. But if you're interested, so our group at Colorado State University has been doing seasonal forecasts. This will be our 41st year, so we've done it currently for 40. This will be number 41 in 2024. We actually have a website, seasonalhurricanepredictions.org, which displays the seasonal forecast from the different groups that you mentioned, and a whole pile more. We have about 30 different groups submitting seasonal predictions. And so some years there is not much spread between the forecasts. There's generally pretty good agreement. In other years, there's a lot of spread. 2023 is a great example of a year there was a lot of spread, which kind of highlights just the uncertainty that we did have with the seasonal forecast last year. There were kind of 2 big players, one being the strong El Nino that developed and intensified over the course of the season. El Nino is warmer than normal water in the eastern and central tropical Pacific. Normally when that occurs, you get stronger winds at say 20 to 30,000 feet blowing out of the west in the Atlantic, and that tends to tear apart hurricanes. So normally El Nino knocks down your storms. But at the same time, the Atlantic always warms up from spring to summer, but it warmed up way, way faster than normal and much faster than most groups anticipated, which is why our group at Colorado State, NOAA, a lot of the other groups, from their initial predictions, say April and May and June, increased their forecast to August because the Atlantic got really, really hot and stayed that way. And normally a warm Atlantic favors an above normal season due to the fact that means you basically have more fuel for your storms.
So let me ask you a question on El Nino itself. So the Atlantic, the Pacific is warm. Atlantic has high winds coming out of the east. Why is it that? How is that, I guess, that air being pulled in a sense from the Atlantic like that? And does that make that question kind of make sense? I mean,
yes.
I'm not familiar with El Nino, and that's what I'm trying to kind of figure out how
'Cause a lot of people, when they hear El Nino and La Nina, they're just kind of like, oh, okay.
Yeah.
And they trigger it. It's going to be an active season or it's not an active season. But there's obviously some science behind it.
Yeah, and so that's actually how our seasonal forecast got started at Colorado State. Bill Gray was the founder of a seasonal forecast, and kind of the way these got started was he was teaching a tropical meteorology class, and he noted when you have El Nino conditions in the tropical Pacific, you get fewer hurricanes in the Atlantic, and that was, okay, you have a statistical relationship, but why physically does that happen? Yeah. And basically, when you have an El Nino, you get really warm waters in the eastern and central tropical Pacific. Normally, your thunderstorms in the tropical Pacific tend to be more located near Indonesia. In an El Nino, they tend to shift farther to the east, more towards the international dateline. So when you have a tropical storm, or when you have strong thunderstorms, you have winds flowing into those thunderstorms at low levels. The air goes up in the thunderstorms, and at upper levels, it spreads outward. And so if you have air going up in the central Pacific, you tend to get more when the air diverges high up in the atmosphere. With the thunderstorms, it tends to come out of the west, which is how it increases that vertical wind shear, which is the change in wind direction and speed with height in the atmosphere. So that's kind of the physical tie of how El Nino impacts Atlantic hurricanes.
Gotcha. Okay. Interesting. Now, when you said Colorado State, this is your 42nd?
This will be year number 41.
41.
Yep.
And here I was saying how, we're doing fifth year claims corner here. I was like, yeah, we're doing something great. And you just throw, like, oh, by the way, we've been doing this for 40-something years. So. But that's why I have you guys on here, because y'all are the experts out there in the industry. Y'all understand. You're just like teaching everybody La Nina and El Nino and those other things like that. There's a lot of people that don't understand that, so they don't see that, which I think goes in a lot of some of your research as well, because we've talked about this earlier. You have homeowners out there, policyholders out there that are living on the coast that watch the cone as it's being forecasted, and they're like, oh, we're good. We're not in the cone. That's okay. We're not going to have that problem. But I think we during one of our breaks, we talked about the ensembles and the models. I am used to looking at getting online and doing a model research and looking like GFS and Euromodel and looking at all that stuff. And that's what I kind of look at and pay attention to. And I look at that and go, oh, that thing's going to be nowhere near me. And the next morning I go in there and do another model run. It's like, oh, it's a little bit closer. And then next morning I do another model run. It's like, oh, well, it's nowhere near close to me. Give me some more information about the ensembles. How do they work? What's behind that? And how does that really tie into the models themselves?
Yeah, and so, historically, a lot of the data has come from what we call these basically like deterministic models, which is basically a high resolution where you basically a model, what you do is you take your observations. So you say, okay, we're going to start a model run at 6 o'clock. Okay, we want to get all the observations in at 6 o'clock so we have the best idea of what the atmosphere looks like now. So we're taking in observations from weather stations, observations from ships, and a ton of satellite data. And then you kind of hit go and the model runs. Well, that's basically what you call like your deterministic model. We also have what's called ensembles, and ensembles basically are similar, but what they do is they say, okay, well, here's the way things were at 6 o'clock, but we know there's uncertainties in all those observations that go in there. So we're going to tweak those observations a little bit to kind of estimate the uncertainty associated with that forecast. And so you can see that with particular hurricanes. There can be hurricanes where your ensemble spreads. So basically, if you run your ensemble, say 50 times, you'll get 50 different tracks for a hurricane. Sometimes those 50 tracks are very close to each other, which indicates in general the model has higher confidence. There's less kind of uncertainty. We saw that, for example, with Hurricane Ida in 2021. Yep. The ensemble spread was very limited. It was very close, so we generally were very confident in the track of the storm. When you look at the National Hurricane Center's forecast track of Ida from the second the storm formed till it made landfall, it moved just a tiny bit. It was almost like dead on. Whereas if you have a storm like a Hurricane Ian, we had the ensembles, and there was a lot more spread in those. And the nice thing with an ensemble is it gives you kind of, it's a little smoother, so it tends to be a little less volatile. So sometimes you'll see kind of like this windshield wiper. Oh, the model says it's going to Mobile, and then the next minute it's going to New Orleans. Well, if you look at the ensemble, maybe it was always somewhere in the middle of Mississippi. So that will kind of give you, it gives you an idea of the uncertainty. And so that's, when we talk about forecasts, always look at what the National Hurricane Center forecasts, because they look at all this stuff and they know it better than anybody else in the world. But it's important to realize that, as you mentioned, that cone that the Hurricane Center puts out, that is a cone based on historical errors. So historically, 2/3 of all Hurricane Center forecast errors would fall within that cone, but that cone is static. So each storm has the same cone, whether the forecast confidence is high or low. And it's also important to realize that that's not an impacts cone. So if you have a very large storm, the impacts can go well outside the cone if you have a really big storm. So it's important to realize, because a lot of people, I think, see the cone and they say, wow, the storm is getting bigger with time. And it's not that the storm is growing. It's just the uncertainty tends to grow with time because as you're further away from what you're trying to predict, just there's less certainty. And I think Hal we were talking about this earlier, Hal had a good explanation, kind of a good comparison when you're driving a car.
Yeah.
Yeah, it's interesting. Let's say you're taking a road trip from Mobile to Houston, right? If you tweak the time you leave Mobile, that may change. If you leave at noon, you're going to get through Baton Rouge at 3 p.m. before rush hour. But if you just move back your departure time 30 minutes, now all of a sudden a small change in the beginning may be a big change in the end, because not only did you leave Mobile 30 minutes later, now you're hitting Baton Rouge closer to rush hour. That could delay you. So all of a sudden you get more and more delays. So sometimes with these ensembles, if you tweak initial conditions, you form the center geographically more to the east, or it forms a little bit later. All of a sudden, small changes in the initial conditions can be big changes down the road.
And you might have to go to the gas station first, and like Phil said, you might have to go to the Chick-fil-A line, and that's going to take a little bit longer than
There's
normal.
just too much good food along the Gulf Coast. I think that's
Exactly. Get distracted.
But the also difference is you either go to Chick-fil-A or you go to McDonald's. Well, you're definitely going to get through Chick-fil-A a lot faster. So, I mean, that's...
The other thing I was thinking, when I heard Phil explaining this, the other thing I was thinking is every forecast by nature is probabilistic. So there's a range of outcomes, right? And that doesn't jive very well with human psychology, right? Yep. People want to know on Tuesday, I got a golf tee time, noon on Saturday. Is it going to be raining or not, right? They just want to know yes or no. And a lot of times that's where they say, these weather people are always wrong. Well, there was a 20% chance of showers, so they started telling their buddies it's not going to rain. But really there's a range of...
still a percent.
There's still a chance, and it's all about chance and likeliness and probability. And humans just want to know certainty. They want to know, where's this hurricane going? Will it be raining for my daughter's wedding on Saturday, right? They want to know definitively. And when you get out 3-4 days into the future, things become more and more uncertain.
Yeah, because, one of the questions I asked earlier during the conference is when, where, how big was this storm going to hit? And then you did not give me a true answer, and I was very disappointed. I thought, you knew the future. You could read the future. But, yeah, that's still valuable to know, because like you're talking about this travel, there's going to be factors that go into that. There's going to be things that you don't run, rush hour, traffic, flat tires, things like that. And I guess that's kind of how the ensembles tend to work in a sense. I mean, the probability of how they kind of come together. Because I always jump on like the GFS or the Euro and look at that and trying to figure out where that's going and what that storm possibly is going to do, and kind of play it by ear. And I think it was we were having a conversation, say last season, and we discussed, hey, I see the storm coming up, and you looked at it and you were like, that's like 360 hours out. And I'm like, and you're like, there's so much that's going to change.
I remember as a young professional seeing these model runs and saying, oh my gosh, this is going to be a Cat 3 hitting Miami. And then friends of mine said, Hal, look at that. That's 186 hours in the future. And I had to say, like, hang on a second. You got to look at the timing, right? So
that question related to that, as the hours get closer, how more accurate does the data become and the percentage become that is definitely going to hit here? Is it usually 3 days out, or is there really does it factor into the storm conditions?
Yeah, and so I mean, usually with time, kind of like your forecast for tomorrow is generally going to be better than your forecast a week from now, but with hurricanes in general, as you get closer, your forecasts of both track and intensity get more confident. But there are still, like, hurricanes even have internal wobbles that really, like, for example, we saw it with Hurricane Laura, where Hurricane Laura had a little wobble as it came on shore. And obviously Lake Charles got hit with a lot of wind, but had it not wobbled a little bit to the east, would have gotten a whole heck of a lot of storm surge too. And so those little wobbles right at the end can sometimes cause differences in impacts as well. So there's less uncertainty in general as you get closer, but there's still going to be some uncertainty. And that's, again, kind of the nature of forecasting.
And is there any science, I guess, or reason why storms just tend to wobble? Because, you're seeing there that it's going this way, it's going this way. But if you ever watch and look at the cone or you look at the track as it's going along, it's just like they're doing this. Is it just the atmosphere? It's the forecast? Could it be potentially the size of the storm?
Yeah, and I mean, a lot of times too, it's how intense the storm is. Sometimes intense storms, when you get those really strong thunderstorms, if there's a little bit of shear, it can cause it to. Basically, you can get these intense thunderstorms that'll cause the storm to just wobble a little bit. There's internal structural things going on with the hurricanes themselves that can cause little wobbles, not like, a big right hook or left hook, but cause little wobbles that, again, depending on how the storm is tracking, can make big differences. And obviously, I think Laura is a great example where I think it, even like a few hours before, it made landfall like 20 miles farther east and was forecast with the final forecast before landfall. And that, again, thankfully made a huge difference. Instead of all the surge going up into Lake Charles, it went into the bayous where very few people live. So from an impacts perspective, it was still really bad because obviously you still had all that wind damage, but we didn't see the massive storm surge that obviously would have probably caused the damage to be much, much worse than it already was.
So I remember back in the 80s, there was a storm, and I don't know the name, it was an O storm. It's during Labor Day, and it was coming up toward Mobile, Dolphin Island area.
Opal.
Wasn't Opal.
Oh, it wasn't Opal.
Wasn't Opal, because that one hit ended up hitting the Panhandle. This one kind of came up, and then it took a right turn and started heading toward Tampa. And it got closer and closer to Tampa. And everybody was forecasting, it's going to hit Tampa, going to hit Tampa, going to hit Tampa. And all of a sudden it just turned.
Maybe Elena, maybe, or something like that.
Maybe it was Elena.
Mid-80s.
Yeah, it turns and starts heading back west.
Kind of did a loop.
It comes right into Dolphin Island.
Okay.
Is just that, again, we're talking about the atmosphere, just that's something the atmosphere would cause, just because I've seen that where storms will just kind of loop around, and it's like, okay, what are they following? Is it just the upper atmosphere pattern? And
yeah, basically you have hurricanes basically behave kind of like a pebble in a stream, and so that stream is generally the mid-latitude flow pattern. So if you have like a really strong high pressure to its north, it'll tend to push the storm to the west. But you can also have periods where, like, if you have, say, like a high to the northwest and a high to the northeast, and the system's kind of in the middle, it'll basically kind of stall. It wwon't move much at all. And we certainly have seen that, for example, in a storm like a Florence or a Harvey or a Sally, where you get these kind of situations where there's basically, basically it's like if a hurricane moves as a pebble in a stream, if the stream isn't moving, the hurricane doesn't move. So, there are cases where basically that'll cause storms to stall, or like a system will track to its north and it'll try to pick it up, but it doesn't quite do it. So the storm will do like weird loops. And if you look back in time, you mentioned like Elena, we have all sorts of strange storms like Hurricane Betsy, which was going off the east coast of the U.S. and then did like a little loop-de-doo and then went through the Keys and then ended up hitting Louisiana. Like,
yeah, exactly.
All sorts of crazy stuff that you see. If you look at all the tracks since the late 19th century, you'll see the storms do all sorts of weird things. And so there's kind of like this prevailing track that storms take, but there's a lot of weirdness, and when you look at hurricanes over a long period of time,
especially if the upper level atmosphere, if the steering patterns kind of break down, it becomes less certain, and all of a sudden forecasters will talk about it typically, I think, slowing down first and then maybe loops and wobbles. I mean, you'll pick that up in the discussions. Usually it'll be known, but it's almost like a known unknown. Like we know it's going to lose a lot of its guidance, and it's going to be less predictable.
And I think something we had, you and I at one point had a discussion about storms getting slower, slowing down more, and then the atmosphere just being more for and flooding and induced flooding like that. I mean, is that still a pattern we're seeing out there?
I mean, from what I've seen with conversations I've had with different modelers, and I did a piece with PBS about this, just the whole purpose of storms is to really move energy and temperature from the tropics to the poles. We know with a warming climate, the Arctic is warming faster than the tropics. So some models and theorists suggest that some of the circulation could be breaking down or slowing down. And it does seem like we've seen a lot of very slow moving or stalled out tropical systems as they're making landfall over the past 6 to 7 years. So the concern with that, obviously, is if a storm is moving through a lot slower, you're just getting a lot more time where the winds are blowing and the rain is falling. And also you have more time where you have strong onshore winds pushing storm surge. So it just can really prolong the storm, which can really increase the impacts quite a bit.
I mean, like we say, the rapid intensification of a lot of storms from, like Hurricane Michael. It was like, oh, it's not going to be bad. And the next thing, we have a Cat 5 hitting Florida. I mean, that's the rapid intensification like that. And another good one, Dorian. I mean, Dorian was in the Bahamas. I think it was a 1 when it was sitting out. And then everybody in the Bahamas was like, oh, we don't have to evacuate. Time it hits, we have a 5. Then it sits over there for 3 days as a 5. I mean,
I shared in my presentation over the past 7 hurricane seasons, we've had 6 Gulf Coast hurricanes that rapidly intensified by the threshold of ramping up at least 40 miles per hour in sustained wind in the last 24 hours before landfall. So again, this has happened 11 times since 1950, but 6 in the last 7 years. And we do think the ocean water temperatures, the Gulf water temperatures are much warmer than they used to be. Obviously, warm water provides fuel for intensification. So it does look like there may be some ties here. Like there could be a trend to this, and it's a concerning pattern.
And that was one of my questions was going to be: you see these increasing temperatures, are they causing intensification? The water temperatures, they causing intensification, more intensification, or is it actually hampering the storm from actually developing more? Have you seen a correlation with that?
Yeah, so in general, we've looked at a rapid intensification. We've looked at it even with some analysis I've done globally. If we look at storms intensifying by kind of the typical definition, which is it needs to intensify by 35 miles per hour in a day. So basically, if a storm is 65 miles an hour and a day later it's 100, it counts as rapid intensification. We didn't see an increasing trend in that quantity, but then we looked at like super rapid intensification, which we defined as 60 miles per hour or more in a day, and we did see an increasing trend in that. And I think that's kind of what we see with climate change in general, is that it kind of loads the dice towards your extreme outlier events. And so in the case of these storms where like I hate to call it like garden variety rapid intensification, not much of a trend, but when you go to like the big outliers, then you see the increasing trend. So these storms kind of last year, probably the best example, when it was not in the Atlantic, would have probably been Hurricane Otis in the eastern North Pacific, where it basically just literally blew up overnight, and suddenly you have a Category 5 barreling into Acapulco. And so that's kind of what we're seeing. And again, there's a lot more that goes on rapid intensification than just warm waters, but as you keep warming them, it kind of loads the dice. So if everything else is conducive and the waters are even that much warmer, you're going to see these storms that maybe 30 years ago intensified by 40 miles an hour, now intensifying by 45 miles an hour or something like that.
And this rapid intensification, is there a way to forecast it? Is there a way to say, okay, hey, we like Otis, for example. We have an example because, we're here in the United States and you have these storms, you look at the models, you hear the news, and they're like, oh, we got one out there and it's 3 days away, and then everybody goes to bed and wake up the next morning, we're like, oh, we got 4 out there now. And they're like, okay, how'd this happen? By then, really, it's really not, you can't prepare. Everybody's thinking of 1, we're good, 4 is bad, but you can't prepare to evacuate. And a lot of people, I think that's what happens. A lot of cases, like we were talking about, some people stayed in these storms, and they lose their lives from it. And I think it's a lot of, they see it as 1, I can go through this, I'm good. But then when they find out the next day it's a 4, is there a way to like really forecast these intensifications? And
so the Hurricane Center, so if you look back, say 20, 25 years ago, and you look at the forecast the Hurricane Center did for intensification, you would not see them intensifying storms as rapidly as they do now. And that's because we have better tools. The models are better. There's some actual explicit tools for forecasting rapid intensification. And so they have gotten a lot more aggressive. And it seemed to me, especially in the last few years, they've gotten a lot more aggressive at forecasting. I think, for example, with Hurricane Lee right off the bat, the first forecast that came out, I think they took it to like Category 4 in 5 days. Like that's, historically, they just wouldn't have done that because they didn't have the confidence. So now we have these tools. Now, it doesn't work every time, and often there can be cases where you think it's going to rapidly intensify and it doesn't. Yeah. And there's also cases where you think it's going to rapidly intensify, and not only does it rapidly intensify, it really rapidly intensifies. So there are, but when you look at the intensity forecast errors from the Hurricane Center, they certainly are going down, and the rapid intensification piece is a big part of that. They are getting better at forecasting that. That's because the guidance tools that we have are just improving. We get better observations, but there's still, it's still a challenge. There's cases, for example, with Otis last year where, none of the models had it, 0. So if no models say it's going to blow up, and how is the forecaster going to forecast it to blow up when they have 0 guidance to say it? And so there's still a lot of work that needs to be done, but it has improved quite a bit. And I think with time, as we learn more, because rapid intensification is both, we need to have the really warm waters, you want to have low shear, so you're basically, your hurricane can be upright, you want to have enough mid-level moisture to kind of help fuel the thunderstorms, but you also need the internal structure of the storm, the structure of the storm itself. And I think that's a piece that we don't necessarily understand quite as well, especially when we're not in the Atlantic and say the Eastern North Pacific, where we don't fly as many planes in. And that's also a critical component of rapid intensification. It's just the environment, but also the structure of the storm itself.
Craig, I wanted to say something with that. I'd encourage people, when you see a National Hurricane Center forecast, to read the discussion. It can be pretty scientific. There may be terminology our listeners don't understand, or sometimes there's stuff in there I don't even understand. But what you'll pick up is sometimes you'll see the forecaster saying, this is a highly confident forecast. All the models are in alignment. And, Phil was talking about this before we started recording. Sometimes everything's lining up. Other times you'll have a huge spread in the model guidance. You'll pick that up when you read those discussions. Even if you don't understand all the scientific terminology, you'll kind of pick up what's going on behind the scenes. And are the forecasters really seeing everything lined up, or are they seeing a wide spread? That can help you as a listener or the coastal resident get a feel for how confident is this forecast. Should we expect it to, whether it's intensity or whether it's the track, should we expect changes, or is this pretty locked in?
It's an interesting point too. It's a forecast. It's not, this is exactly what's going to happen. It's a forecast, which is concerned in a sense but it's the way it is. But you have, people out there, you have a rapidly intensifying storm. It doesn't happen because it was a forecast, and they think next time there's a storm, it's not going to happen again. It's just like we want to see, is it really going to rain today when I play golf? Well, there's a 20% chance, and then you go out there and it rains. Well, there was still that percentage that was going to happen. So, it's kind of hit or miss, but it's when it comes down to like storms and hurricanes and things like that, as you're reading the National Hurricane Center and the prediction and everything, you have to pay attention to those, and you have to make sure you have an action plan ready, you have the gear ready, you're ready to move out of the harm's way if it's going to happen, and you're ready for that. And if it doesn't, you plan for the next one, because you don't gamble your life on something just because, what didn't happen this time, it's not going to happen again.
Craig, I was so impressed when we did the GeoTrek podcast episode in Hurricane Ian. I interviewed a resident of Sanibel Island. They just got terrible damage. People died in this area. This resident prepared his home. He saw the forecast track was near or north of Tampa, but he still prepared his home just in case it shifted. When the forecast shifted, he could get out in about 30 minutes. But I thought that's what we have to do, right? You're looking at the forecast, but you're still anticipating, what if this shifts? I may need to get out of here real quickly. And just talking to someone that, took a direct hit, but escaped with their life and some of their possessions because they anticipated there may be a shift in the forecast. When it did shift, they could get out in like 30 minutes. That's what we need to be doing when we look at these forecasts.
So, 2023 was kind of hit or miss. Some said yes, a lot. Some said no. A lot of them went out to sea. Everybody's like, okay, we were good except for Adelia that kind of hit the panhandle. What are we looking at 2024? What's and just briefly, you don't have to go into a lot of detail, just briefly. Are we going to get storms or not? That's a terrible question.
Well,
to ask, but
the answer is yes, we will get storms. Where they will go and how strong they will be, we don't know. No, but so, it's still really, really early. And so the hurricane season officially starts June 1st, but doesn't really ramp up until August. We saw a great example of that in 2023. The season was kind of dinking along through about August 20th, and then the season just ramped up super fast, and we had a ton of storms from basically August 20th to the end of September. And so in 2024, that El Nino that we talked about earlier is very likely to be gone. And so that, again, normally knocks down your storm. So with that not being there, that's not great for the upcoming season. But we also don't know right now. The Atlantic, which was record warm last year, is still extremely warm. But a lot can change during the winter months. The winds blowing across the tropical Atlantic tend to be pretty strong this time of year. So if the weather patterns are one way or the other, it can make either the water stay extremely warm. Obviously, if we take the El Nino out of the picture and we keep the Atlantic as warm as it was last year, this year coming up, that would be really bad. But there's a lot that can still change. So we'll put out our first forecast on April 4th, and a lot of the other forecast groups that you mentioned also put out a forecast sometime between middle to later part of March through the middle of April. So there'll be a lot of different people looking at things and kind of coming up with numbers. Some of the early forecasts that have come out have been extremely aggressive, but there's not a lot of skill at this lead time. So I wouldn't necessarily get too worked up about anything at this point. We got a long way to go, so we'll see what happens. For example, last February, if you look at the water temperatures end of February, you'd say, the Atlantic's kind of near average, nothing really to worry about. Yeah. And then by end of May, holy cow, it's record warm. So a lot can change just with atmospheric patterns in a couple of months.
But as we talked about, it's always good to be prepared. To
Correct.
start preparing, to have your emergency kits in order and everything like that. I mean, just always have it handy all the time. So future forecasting. Let's talk about that for a minute. You all have a focus on hurricane damages correlating better with air pressure than wind speed. Can you elaborate on this?
Yeah, so this is some work that really I got really fired up about this because I grew up in Massachusetts, and I feel like the hurricanes up in the Northeast U.S. and even in the Mid-Atlantic states don't really get respect. Often their categories are kind of low for really what the damage that they cause, and a lot of that's due to the fact that we currently categorize hurricanes by maximum wind. So the strongest winds that the hurricanes have. And that's fine. I mean, it does correlate with the damage, but that really doesn't tell you very much about the size of the storm. And larger storms tend to have just a larger area where you get rain and a larger area where you get wind, but they also tend to have more storm surge. And so a way you can kind of get at the size of the storm is by looking at the pressure in the center of the storm, so in the eye. So if you have a very low pressure in the eye of a storm and the winds aren't necessarily quite as strong as you would expect, that means the storm is very large. And a great example of this would be a Hurricane Katrina in 2005 or Hurricane Ike in 2008. Those are very kind of large in size storms where the winds they were high, but not necessarily as high as you would have otherwise expected. But they were huge and had enormous storm surges associated with them. And obviously, Hal can talk to both the surge, especially I know given where he lives, he can certainly talk with you a lot about the storm surge that they saw with Hurricane Ike, which was just a Category 2. And there were a lot of people that said, "Oh, we're not going to evacuate because it was a Category 2. If it was a major hurricane, we get out, but it's a Cat 2, so we're fine." And then you saw the storm surge, and the Bolivar Peninsula was basically almost wiped clean.
Yeah, we consider major hurricanes to be Category 3 or above. Maximum sustained winds of at least 111. Ike was just below that. So Ike wasn't officially a major hurricane, but with a 17.5-foot storm surge, it just wiped the Bolivar Peninsula clean. I mean, dozens of fatalities in there, terrible damage. I mean, complete economic and property damage was almost complete in that area, but not a major hurricane because, as Phil mentioned, it was not a major hurricane. It was an upper-level Cat 2 according to the wind. Geographically, the size was enormous. And what Phil was saying there, the air pressure for Ike is more of what we typically see in a Cat 3 or Cat 4. But because it was so geographically huge, it only was a Cat, only quote unquote a Cat 2. And that ties into, a lot of people said we don't evacuate for Cat 2s. Just if it's a 3 or higher, we'll leave. Well, all of a sudden their house is being washed away and they're drowning in the middle of the night. So that's where, the pressure really, when you consider the air pressure, you're considering the intensity, but you're also considering the size, and that both of those tie in really well with coastal flood risk. So I really love this work that Phil and his team are doing there, looking at pressure as far as a categorization of a hurricane, as opposed to just looking at maximum sustained winds.
Yeah, and I should pitch also, the two of us are actually working together on a paper. It's been shown before, but tying together the relationship between wind pressure and storm surge. And we can show how it has this great data set of the maximum storm surge from each hurricane since 1950 that's hit the U.S. And if you look at just that maximum storm surge and you correlate it with wind, it's a positive relationship, but you get a better one with pressure. And it's pretty amazing because, Hal's the storm surge expert, but there's a whole lot of stuff that goes into the maximum storm surge with a hurricane. You have a lot of it's the geographic shape of the coastline and how that works, but just knowing the pressure does tell you more about the storm surge. It tells you more about the size of the storm. And if you look historically, it correlates better with the damage than does wind. And it really also, more importantly, correlates with fatality. So if we look historically, using wind as your metric since like the late 80s, about half of all storms that have killed 10 or more people were classified as major. If we use our pressure-based scale, it's about 85%. So you are warning more on the high-end events using pressure, basically by saying these storms may, some of these storms that, may not have the strongest winds, they're big, so they're going to have a larger area that's going to be impacted, and also larger storm surge. And certainly we saw, Ian or Ike was a Category 2, but had a 17-foot storm surge. Katrina was a Category 3, had a 28-foot storm surge.
Correct.
So, that's a cartoonish level of storm surge. So surge does correlate with the intensity, but it's also a really big driver is the size of the storm, and you can get at that pretty well with pressure.
And you both kind of brought up a good point as well. Is you got a Cat 5 like Katrina, and everybody's all upset about it, having issues about it, trying to evacuate, do whatever, and then it loses intensification, or it gets downgraded to a Cat 3 than anybody says, oh, we're good, but you still had a 28-foot surge come in because of situation like the pressure. So let me ask your opinions, and we can edit this later. Do you feel like the categories should be eliminated? Is that a mischaracterization of a storm when you're looking at a Cat 3, Cat 4, Cat 5? You're looking at a minor or a major or tropical storm, because it sounds like minor storms still can cause significant amount of damage just like a major. But as you're talking about major, immediately people get upset. People start getting worried. But then as soon as you downgrade it to a minor, everybody relaxes a little bit. And when we were having that conversation, when you're saying minor and major and everything, I was like, oh, yeah, I'd be okay if it was a minor because it's only a 3. We're good if it's a 3. But when we start talking about 4 and 5, you start to worry. But we still have issues where a 3 still is impactful.
I mean, flooding kills a lot more people than wind. I mean, it seems like, from what I've heard, storm surge kills historically about 50% of people from direct hurricane fatalities, and rainfall-induced flooding on some of these stats shows maybe 25%. So you combine those and you're looking at flooding, these are general numbers, but maybe about 2/3 to 3/4 of the deaths are from flooding, but we classify hurricanes based on wind. And so for me as a hurricane communicator, I think my personal opinion is that the Saffir-Simpson scale, the hurricane wind classification, I think it does probably more harm than good, because a lot of people are making life and death decisions based on the wind category when flooding kills a lot more people than the wind does. So as a hurricane communicator, it puts me in a hole I have to dig out of. I have to say, although it's been downgraded to a minor hurricane, your 30 inches of rain just started. I have to use all those statements all the time. Although it's been downgraded to a minor hurricane, we're still forecasting 12 to 16 feet of storm surge. So I feel like it puts you in a hole you have to dig out of to tell people this is still very, very dangerous, even though it's been downgraded.
Yeah, and it's all hard too. Like I cringe, even like when I'm reviewing scientific papers, how many people will call like a Category 1 hurricane a minor hurricane, and it's like, okay, maybe it's not a major, but no hurricane is minor. Like just the winds associated with that are going to cause some damage, and obviously you've got the surge and the flooding. So but I can tell you even in peer-reviewed journal articles, I'll call them minor hurricanes, and I'm like, I personally don't like that term. But I think from a warning perspective, there's certainly no one number that is going to categorize all the impacts. And if you're going to do a 1 to 5 scale, I think in general the public needs some sort of 1 to 5 scale, because if you tell someone there's 9 feet of inundation of storm surge, like I don't think a lot of people necessarily quite understand what that means. But if you can give them, a lot of it really boils down to, okay, do you need to get the heck out, or can you shelter in place? And that obviously that emergency managers understand what 9 feet of storm surge inundation. They know which zones need to evacuate. And so I think, a lot of the time, especially unless you're right along the coast, if you're in a well-built structure, you don't necessarily need to go anywhere, or you just need to go a couple miles inland to a well-built structure. And, we were talking about that even with Hurricane Ian, and we saw it especially with Hurricane Irma, because that storm scared the snarf out of everybody. The entire state of Florida evacuated. My brother was heading up, and he said they couldn't find a hotel room to North Carolina. It was just insane how far people were evacuating from that storm. You don't necessarily need to go that far. You can, sometimes only a mile or two, just get to a well-built structure elevated above the surge zone, and you're fine. And, obviously it makes it a lot cheaper, and you're not out of your house for, if you're going 1,000 miles away, you may want to go visit family anyway, but otherwise, driving 1,000 miles, that's really expensive, and then, it gets costly. So I think really the key is, when we're messaging storms, I think a 1 to 5 scale is useful, but I think that just basing it off of wind isn't great. I think personally, my opinion is we use pressure to kind of give you an idea of the storm intensity, and we need to message flooding differently, because the correlation between flooding and storm intensity is marginal. So a lot of it is how fast is the storm moving, like Hal mentioned earlier. If you have storms that are moving slowly, they're going to cause more rain just because they're taking longer to get the heck out of town. But you also have to deal with things like topography. If it's interacting with mid-latitude systems, that can increase rainfall, like we saw with Hurricane Ida. When it moved up into Pennsylvania, New York area, it brought tons of flooding up there. And even I kind of like, okay, the storm's done. I wasn't paying that much attention. I put on the U.S. Open because I like to watch tennis, and I was like, holy cow, it's raining, And then my aunt lives in New Jersey, and it's like, Phil, there's boats going down our street. So, these storms can kind of keep... once a storm makes landfall, it doesn't necessarily mean that the threat is over. And Hal did a great, we're talking about even Hurricane Camille yesterday.
People make the false assumption that the higher the category number, also the higher the flood risk. I mean, look at Hurricane Harvey. When most of Metro Houston flooded, it was really a Cat 0. I mean, it was a tropical cyclone.
Storm.
But the winds were not even hurricane force, but they still were looking at 40, 50, 60 inches of rain. So again, you don't need a high category system. A stalled out system dumping 40 inches of rain, you're going to have a lot of problems.
And I know when you forecast, I've seen your post on social media, you forecast, you have your little chart. It's like, hey, this is a real high probability of wind. This is a medium probability of surge, and I think there's another one in there.
Yeah, I try to use just plain language. I just break the storm into rainfall, storm surge, and wind, and just use plain language.
It's like
where
white, red, and yellow, or white, yellow, and red. So it's like, okay, obviously red is like, okay, we've got to do something here.
Right, and for example, when I say something is probable, for me, I mean the chance of that just went over 50%. So for me, for example, under 50% is possible, more than 50% is probable. I'm trying to use plain language in these ways, but I agree with what Phil said. These are multi-hazard events. We need to think of you can't classify a system that's giving you wind, rain, and storm surge by just one number. I mean, really, you have 3 different hazards coming in. How can you classify that complex system with just one number? And
as we see, once it makes landfall, the winds die, but there's still that risk of severe flooding. There's still the inland flooding, flash floods. There's still a risk there that, as far as we saw all the way up in Virginia, we still have a risk.
I remember working Hurricane Florence in the Carolinas in 2018, and I was in this hotel, and they said it's been downgraded, and everyone in this hotel lobby said, "Oh, thank God." We just started our 30 inches of rain, and who cares if it's been downgraded if you're going to have 12 feet of water in your house tomorrow, So again, that whole concept of downgrading just based on the wind category. And it's like, well, I get that, but our danger here is, in that case, rainfall flooding.
Okay. Cool. Well, gentlemen, it's been a great honor to actually sit down with you during our conference here and have this discussion. Your research that you've done over 41 years now, that you've involved in. So the research we're involved in and the research y'all are doing. I mean, like I said earlier, I was like, we've been doing this for the 5th season of Claims Corner. I was really excited, but then I get some experts in the industry who really understand the dynamics and what the forecasting is and also what you're looking at, how to go about, changing it in a sense to better educate and better inform the policyholder, the insured, as we deal with them as on the insurance side, and really just the consumer out there that needs to hear what's happening so that they can better protect themselves when events are happening. So this has been a great conversation.
Craig, I want to say off the record, Phil was telling me there's going to be a landfall on August 18th at 8:30 p.m. in a certain Gulf Coast city. Can we talk about that on the broadcast?
Gulf Coast City. Okay.
Yeah, maybe we'll talk about that off the record.
We could definitely talk about that.
He has more precision than he lets up. No, I'm joking around, but great conversation, guys.
He went up to the fortune teller machine and put the quarter in. And like,
right.
This is where
the magic 8 ball told me. Probability likely.
Probability looks awful. So this has been a great Claims Corner. I don't know what the title of this. It's more like a conversational piece. It's the casual conversation at the CNC Connect conference
with Craig.
All
C's.
Craig, yes. How we can do a casual cyclone conversation?
Casual cyclone conversation at the CNC Connect conference with Craig. That's like 6.
Perfect.
It's like 6.
There we have it.
There you go. You got all alliteration.
Phil, thanks. I really appreciate you coming down and being at our conference. It was a great honor to. I mean, like I said, I've seen you many times and just your picture and forecasting. So it was great to meet you. And Hal, it's always good to see you. And so, really appreciate y'all's time. Thank you.
Yeah,
thank you. So it's been great to be here.
Yeah, thanks so much for having me.
Absolutely.
All right. Fantastic segment there from our own Craig Fowler and Hal Needham, as well as Phil Klotzbach. We are super thankful, obviously, that we were able to catch some time with them at CNC Connect. It was a busy event, a lot of people, a lot of classes, a lot of sessions. So for those 3 to sneak away and do that pre-recording for us, knowing that we would be able to utilize it at some point this year, we're obviously very thankful for that. Last couple things we want to do today. First thing is we want to jump into our I Yow segment of the week. We have been doing these every episode That's right, IYOW, in your own words. So again, this week's In Your Own Words segment is brought to you by Blue Leopard Agency, a marketing agency that's redefining success in the digital age. Visit blueleopardagency.com today to discover how they can tailor a marketing plan that's as unique as your brand. Don't wait. Take the first step toward marketing success right now. So this question is for both Hal and Phil, whatever order you want to go in. This week is going to be in your one word. So we're going to do a little twist on it. One word. What is the one word you would use to describe this upcoming hurricane season? I know a lot of people are anxious to hear this. One word.
Phil, why don't you go first with that one?
Pass the buck.
All right, I would say robust.
Okay.
Robust.
I was
Robust.
thinking active.
All right. I think those are two good words that a lot of people want to
Can I
hear.
throw one out there too?
Yeah.
Questionable.
Yeah.
And why do I think it's questionable?
I was
don't
gonna
know.
I was gonna say
That's why
unknown.
That's actually why I'm going to ask Phil this question. So I'm going to put him on the spot. So yeah, I actually want to ask this. So since we did this broadcast, which was back in January at our office at a conference in Mobile, what changes have you seen or have y'all seen in the 2024 forecast? What changes? What's out there that would make you think, all right, we're going to have a robust season this year, or we're going to have a questionable season still? What do you think? What changes have y'all seen?
Yeah. So one of the big things is that we haven't seen a lot of change in the Atlantic in terms of the anomalies. So the Atlantic is still extremely warm. And so there's still a lot that can change between now and when the season really ramps up in August. But, as Yogi Bear, I used to say, it's getting late early. Like we're going to have to start seeing some big changes in a hurry because a really warm Atlantic provides more fuel for the hurricanes and basically just should likely lead to a well above normal season. The other thing that has changed since January is the El Nino, which was quite strong when we talked in Mobile, has started to weaken, and it looks like it's kind of on its last legs and probably will transition over to neutral conditions in probably the next, say, 4 to 6 weeks. The big question is, will we get all the way over to La Nina, which is colder than normal water in the eastern and central tropical Pacific? NOAA's betting pretty aggressively well. I tend to agree. I think their odds for August through October, which are the peak 3 months of the season, is over 80%. I would agree. I think the odds of La Nina for the peak of the 2024 season are quite high. Normally, when we have La Nina, that increases Atlantic hurricane activity, decreases levels of vertical wind shear, which is that change in wind direction and speed with height in the atmosphere. Too much shear tears apart hurricanes. Less shear is more conducive for them. And really, when it comes to impacts, what that tends to lead to is more frequent landfalls, especially along the east coast of the United States. It doesn't change as much for the Gulf, but for the East Coast, you tend to get more systems forming right off of Africa. And those systems can make it into the Gulf, but that's fairly rare. They're more likely to, say, track basically west-northwest across the Atlantic, potentially impacting Florida and further up along the East Coast. So that's kind of what we're looking at right now. We put out our first formal forecast on Thursday, April the 4th. It'll be at 10 a.m. Eastern time that day.
Okay.
Making your notes.
Got Florida target now. So what would make the, you said robust and kind of aggressive, what would change that? What would make the forecast kind of go down? What would be a factor?
Yeah, so one of the reasons why the Atlantic has stayed so warm, I mean, obviously it cools every year from summer to winter. But why it stayed so much above average is because we haven't generally had very strong winds blowing across the tropical Atlantic. Those winds, the trade winds that blow from east to west in the tropics, have been fairly weak. And so when you have weaker winds, you get less evaporation. It helps keep the waters warm. So basically, if the subtropical high, which has generally been very weak for the last almost a year, if that were to suddenly re-strengthen quite a bit and we got much stronger winds, that would cause potentially a significant cooling. Honestly, one of the things that people have said, like they want to soundbite what would cause a big change, would be a major tropical volcanic eruption. Obviously, if something like that were to happen, that would just cause significant cooling, around the tropics. Obviously, those you can't really predict. So certainly what we're looking at right now is really if the subtropical high were to get, quite a bit stronger,
something we're always watching. The models don't do a great job of forecasting the strength of that more than a couple weeks out. But at least in the short to medium term, we don't really see any signs of the winds strengthening dramatically for any prolonged period of time. So unfortunately, it looks like we're very likely to have a continued warm Atlantic. I did look at one thing just the other day and said, okay, say the Atlantic warms at the slowest rate that has been observed to warm between March and September. How warm would the Atlantic be then in the main development region where your major hurricanes tend to form? Would still be the second warmest on record, even if it warmed at the slowest rate that it has in the past 40 plus years. So that's concerning too, is that, not that it's a foregone conclusion, but even if it warms slower than normal, it's still going to probably be an extremely warm Atlantic, just given how warm it is now. There's only so much I think the atmosphere can do at this point. So, again, not a slam dunk. It's April. A lot can change, but right now, certainly we're leaning towards a well above average hurricane season. And again, our outlook will come out in about 2 weeks.
Okay, cool. I think that leads into a question, Julie. I think there was a question on our chat about Sahara dust.
Yes.
And I think that would be a good segment into that. Can you pull that question up?
Yes, sir. It says, does the annual African dust storm affect the formation of storms?
Yeah, so typically one of the reasons, Atlantic hurricane activity is very peaked. So the season starts June 1st, and June and July are normally very, very quiet. I'm doing a presentation next week on the 2004 hurricane season, which was an extremely busy season, lots of landfalls. But June and July, we had 0 storms. Nothing happened. And then August came about and it got very busy very, very quickly, and was an impactful season. And so one of the reasons why June and July tends to be quiet is because while the vertical wind shear tends to be fairly low, especially once you get in the mid to late July, the atmosphere is kind of dry. The waters tend to be too cool in the eastern tropical Atlantic, but there's a lot of dry air coming off Africa. That tends to start, those dust outbreaks and dry air tends to start to kind of weaken as you get into early to middle August, which is why Dr. Bill Gray used to ring a bell every year on August 20th, signaling the active part of the season, because that's when the storms really, really ramp up. We certainly saw that last year. Got really busy around August 20th. So yeah, basically the dust coming off the Sahara can significantly impact storms in the short term, but just because you see dust coming off Africa doesn't necessarily mean the season is going to be quiet, because vigorous African easterly waves, which are these strong thunderstorm complexes that come off of Africa, tend to be associated with robust dust outbreaks lagging them. So, for example, 2020 had a monster dust outbreak in late June, and obviously 2020 was anything but a quiet hurricane season. We had 30 storms in 2020. So, again, that's often you will see a fair amount of dust in June and July, but even if you see a lot of dust in June and July, and if you say June and July is fairly quiet, doesn't necessarily mean really anything for the peak of the hurricane season. Again, the Atlantic season is jam-packed. August, September, and October is when 90-ish% of your storm activity occurs historically.
Interesting. Okay. A question that I was thinking about earlier is there any geographic areas that concern y'all? Is there any place that you say, hey, this, pay attention? Or is that a loaded question?
Oh, Hal, I think you had an answer for that.
Yeah, something that comes to mind are places that have had a lot of near misses. So like where I live along the upper Texas coast, we've been in the bullseye several times in the past decade, but a lot of those storms recurved up to the north and hit Louisiana. The western Florida coast near Tampa, St. Pete as well, they've been in the crosshairs, but they've had storms hit to the north, like where Michael did in 2018, Ian to the south in 2022. And you start talking to people in those regions, and they really start to form some kind of a thesis that hurricanes just always miss us. Those areas concern me because I just see a lot of complacency that people aren't taking the early warnings. They're saying, oh, just wait, it'll curve. And then all of a sudden, they're 12 hours out from a landfall and it hasn't curved and it's too late.
That's a really good point.
Yeah, I think so. The Indian Burial Grounds in Tampa, does that have, is that a myth?
Yeah, so when I spent time along the western Florida coast there, I started hearing people say, oh, we're not worried about hurricane landfalls at all. We have ancient Indian burial grounds that protect us. I thought the first person or two was just joking, but after I heard this for the eighth or ninth time, I'm like, okay, this is actually a local legend. And so the legend, there are different versions of the legend, but essentially they feel that these Indian burial grounds protect them. And I think what's happening again, they're looking at the climatology. They're seeing a lot of these storms curve and not hit them, and then they're trying to find an explanation. But a good way to counter that is by going back in time far enough, and you see hurricanes like 1921 in Tampa, a 10.5 foot storm surge. And then way back in 1848, the Indian burial grounds were there, but Tampa had back to back major hurricane landfalls with a 15-foot storm surge and a 10-foot storm surge in September and October of 1848. So again, you go back far enough in time, and a lot of these urban legends kind of dissipate, and they're proven to be not true.
So basically, follow the science, the data, and the historical, specifically the historical data, like um, like the
Craig, if
stuff
I
we
could
do
just
with.
say one thing on it, and then I'm curious what Phil says, but I think sometimes people start making theories based on a really small sample size. So in a given area of coast, maybe you've been threatened by 4 hurricanes in 25 years, and so maybe 3 of those 4 are shifted to the east, and so people start making a thesis, or okay, I've been here a long time in their mind. They start making these conclusions based on a really small sample size. Phil, I'm curious if you would agree, but when you go back to like the HERDAT data set, going back to 1851, a deeper data set, 150 plus years, all of a sudden you start to see a lot of patterns that maybe take away from some of those recent decades. Would you agree with that?
Yeah, I mean, I think that's really important when you're looking at landfalls, especially because obviously landfalls are a very small subset of the storms that occur in the overall in the Atlantic, and so you can have run really good or really bad streaks of luck. Obviously, if you were in Louisiana in 2020 and 2021, that's not your quote unquote normal rates of landfall. That's not what that if you look at the long term rates, that was an extremely elevated period. But also Florida, I mean, we had 10 years in Florida where it didn't get hit by one hurricane. I mean, if you got into Vegas after '04 and '05 and said, I'm going to bet no hurricanes hit Florida for the next decade, you would have gotten some really good odds and probably made some really good payouts at the end of 2015 betting on that. So it is important to look at these longer term data sets and try to get a better idea of really what the risks are, because again, I think you're right. People look at the last year or two or 5 years, maybe tops, and they say that's kind of our risk, and that's what happens. And so, obviously, especially in this day and age when people move around a lot, there's a lot of people that are new to an area, and if they don't have something for a year or two, they think, okay, hurricanes aren't a problem, or hurricanes are a problem every year, depending on where they happen to move to. So it's important to look at these longer term odds, and especially I think Tampa's a great case in point where we've had basically one hurricane hit Tampa very significantly since 1850, but as you mentioned before, we had 2 hurricanes hit in 1 year in 1848 right in Tampa. So it's important to look at these longer term records to get a really better idea of what the overall risk is for any particular part of the coast.
And that's a good point. That's something how you do on the FIS flood information systems is pull that historical data. So it's not, you got to pay attention to history, basically, and follow history, because with the Indian burial ground myth, I mean, it's a myth nobody's been hit in a while, so there's complacency there, and people think, okay, it's going to pass us. But let's look back at the historical data and factor that in as well, because with like Philly, like you talked about, a robust season. We don't know what that season's going to lay out for us when it happens, but we have to, as a consumer, as a homeowner, and just as a part, we have to be prepared for these things. We have to be paying attention to the cycle of what's happening out there in the forecast, and pay attention to the models, and pay attention to what happened, and have a game plan ready, have an emergency plan ready, because it may be that one unfortunate opportunity, that event that you are not prepared for because you've been so complacent, or you've moved, or you've been to a situation where okay, this hasn't hit us in 14 years, 15 years. What are the chances? You don't want to take that chance. We always have to kind of be ready for that. So, Nora, almost out of time here. Julie, do we have any more questions?
Just one more.
Okay.
What are your thoughts on LRC pattern?
Julia, what are your thoughts on LRC pattern?
Yes.
Was there a clarification on that, or did they spell it out?
No, sir, they did not. John, what
Phil,
is
do you know what they're getting
LRC?
at there?
Left, right, center. I know it's a dice game.
Yeah. Yeah, or a long range something. I don't know. I'm not familiar with that. So we may have to have them follow up or clarify by email. You know what I
Okay.
love about Claims Corner, we're on so frequently, we can often address a question on a future episode as well.
Very true.
Right, and you can email me, John, and I can ask them and get back to you. I'm going to put my email in the chat.
Perfect.
All right. Well, I guess with that we'll wrap it up.
Yeah.
We really appreciate Phil joining us from Colorado and Hal from Texas, and we're like Murphy and Julie there in Mobile. I'm up here in New Jersey. It's great. It's great technology here that allows us to get together and actually have these conversations and bring up some really valuable information and points for understanding, like I mentioned earlier, just being hurricane prepared, being storm prepared, understanding what we may see this year. And I wrote this down. I'm not sure what that means. That I don't know if that's a state, but I just heard that word point out there, so I just wanted to point that out there. And we just take that with a grain of salt because you don't know what's going to happen until it happens. But we just continue to follow your guidance and your tech and your data out there, and hope for. I don't want to. I won't say hope for active season or inactive season. I'll be neutral with this.
There you go.
All right, Murphy, you want to close us out?
Yeah, again, just want to thank everybody for being here. Obviously, thank you to our guests, not only for meeting with us back in January, but for today as well. I know Phil and Hal are both extremely busy with, getting projections ready and doing their own research so they can get that info out, not only to our listeners, but other people as well. So, again, we appreciate everybody being here. Appreciate everybody behind the scenes that nobody gets to see that makes all these broadcasts possible. But other than that, that is all I have got for today. See you, everybody. There you go, Craig.
And I got this one too. I just found this one the other day.
Yeah. End it with the hearts. There you go.
Yeah, thank you all again, Phil, Hal. Thanks everybody. Appreciate y'all being on. Y'all have a great day.
All right. See you, everybody.
Bye.
Take care. Bye bye.